Hi everyone, myself Manisha, and in this video I'll be explaining about image classification project using deep learning. So let's start the video and get into the project.
For building image classification project, I have used the technologies deep learning technology, Python programming language, and open source for deploying my project that is TensorFlow. And I have used Google Colab to write all those codes. Next, let me explain you what is deep learning. Deep learning is nothing but it is a subset of machine learning which will be predicting the data or the which will be predicting based on the neural networks. For image classification, we'll be using CNN algorithm, which is nothing but a convolutional neural network. So this is the best algorithm for training as well as testing image classification model of deep learning. So this algorithm consists of 4 layers: convolutional layer, ReLU layer, pooling layer, following with fully connected layer. So now let's get into the deep how CNN algorithm works. So let us consider that this is an image and consider that image is an X. So CNN works by dividing the image into parts. So if the image is X, so this image has one component, right? This is the first component, second component, second component, and the third component is the intersecting point. So this is the third component. So this image will be converted to a pixels of images. By default, image size is by default the pixel size is 9. So this will be converted to 9 pixels, which is 9 rows and 9 columns. So wherever the image is present there, one will be replaced, and wherever the boxes are empty there, -1 will be written. So convolutional layer, it compares this component with the image and calculates and calculates by adding all those values, by calculating all those values and dividing by the whole number, we get a value. So that value is written in a matrix. In a similar way, the whole image is converted to a matrix. So that matrix is next followed to the ReLU layer, which converts 0 or negative numbers to 0. That is, less than 0 will be converted to 0 and greater than 0 will remain as it is. After that, we get a ReLU matrix. That ReLU matrix is followed for the pooling layer. Pooling layer is nothing but grouping 4 members. That is, if this matrix has, if this image, that is, if the ReLU layer has 9 cross 9 matrix, that 9 cross 9 matrix will consider 2 cross 2 matrix. In that 2 cross 2 matrix, we'll pick out the best member. In the 4 members, the best member will be picked and it will be stored in one matrix. In that way, we'll be reducing the size of the image. So pooling layer main purpose is reducing the size of the image. After that, after pooling layer, we get a matrix. That matrix will be written in a list, in a vertical list, and that we call it as vectors. So these vectors are used for the classification of the image. This is how CNN works. Now let me say what is my project overview. So I'll be taking a image of a shoe and then I'll apply CNN algorithm on that, and which will predict the shoes. So let's get into the project code. I have written the project code in Google Colab server. Here I have imported all the dependencies. TQDM is for the progress bar, and PIL, this is for reshaping, resizing the images. Random is for shuffling the image in a random order, so that while testing we won't get in a order wise, it will come in a random order. Next, I'm saying that If the shoe is Nike, then our output will be nearly equal to 1, comma 0. Else, if it is Adidas, our output should be 0, comma 1. If this is the output, then then the model is working properly. So in this cell, I am resizing the shape. I mean, I'm resizing the image and also converting the image into gray color, because if I have if it is in a gray color, then size will be reduced and runtime will be faster. I'm importing class from TensorFlow. TensorFlow is an open source for deploying machine learning and deep learning projects. From that, I'm using the Keras API. So for Keras API, I'm adding all the hidden layers. This cell represents I'm adding all the hidden layers, and by using optimizer Adam and categorical cross entropy, I'll be calculating loss. So now let's run it. After reshaping, now let's train the model. Let's do the epochs of 10. It will do backward as well as forward propagation 10 times. So here you can see that accuracy is 0.58 and loss is 89.77, which is huge loss. But when it came to 10, it reduced to loss reduced to 0.54 and accuracy has increased to 76 percentage. Now, since our model is trained with the optimizer Adam, now let's test with the predict function. So for testing, uh, I'm taking the path of this image, and I'm converting the image to gray color again. After that, I'm testing using predict function. So here we can see that the output is 0.068 and 0.93. So 0.068 will be 0.01, sorry, 0.1, which is nothing but of 0, and 0.93 is approximately equal to 1. So 0 comma 1, if we go up here, 0 comma 1 is for Adidas. It is for Adidas. And the shoe on which we are testing is also Adidas. So, so in this way, I can say that my project is running properly. This is all about my project. Thank you.